Today, we're diving into the world of mobile application testing. We'll explore common test types and the unique levels that come with mobile development. Then, we'll look at experience-based testing methods before moving into test processes and lifecycle approaches. Finally, we'll wrap up with a practical exercise and a real-world case study. Let's get started. When we talk about testing mobile applications, there are several common types that come into play. These tests help us make sure the app works well, feels smooth, and meets users' expectations. We look at functionality testing to check if everything operates as it should. Then there's usability testing, which focuses on the user experience. Performance testing measures speed and responsiveness. Security testing protects user data. And compatibility testing ensures the app works across different devices and operating systems. Each type plays a vital role in delivering a quality app. When we talk about common mobile app tests, there are a few key areas we focus on. Performance testing checks how fast the app launches, whether cold or warm, monitors frame rates for smooth visuals, measures API response times, and tracks memory use. Security testing looks for weak spots like unsafe data storage, hard-coded keys, unencrypted traffic, and ways SSL protections might be bypassed. Installation and upgrade testing covers everything from fresh installs to updates that keep user data safe, plus uninstall processes and over-the-air patches. These tests keep apps reliable and secure. When we talk about mobile performance testing, it's easy to focus just on server response times. But there's another crucial factor: cold start time. That's how long your app takes to launch from a completely closed state. If it takes more than 3 seconds, users start dropping off fast. So, keeping that launch time low is key to keeping people engaged and coming back. When we think about testing mobile apps, unit and integration tests are just the beginning. There's a whole world beyond these basics, additional test levels that help catch issues real users might face. These include things like UI testing, performance testing, and even security checks. Each layer adds confidence that our app won't just work in theory, but will thrive in the hands of actual users. Let's explore these extra steps and why they matter so much in mobile development. When it comes to mobile apps, testing goes beyond just the code. We start with field testing, putting the app through its paces in real mobility scenarios. That means walking, riding trains, or switching cellular towers to see how it performs on the move. Next, beta and crowdsourced testing lets us gather feedback from actual users, often through platforms like Apple TestFlight or Firebase app distribution. Finally, store compliance testing ensures everything meets Apple and Google's rules, from metadata to privacy policies and design guidelines. These extra layers help us deliver a polished mobile experience. Store compliance testing is a challenge unique to mobile software engineering. No matter how solid your code is, if you don't follow Apple's human interface guidelines or forget to disclose data tracking permissions, your app will get rejected. That means delays, and delays mean your product launch gets pushed back. So, understanding these rules isn't just a formality. It's essential to getting your app into users' hands on time. We're diving into why scripted testing alone just doesn't cut it. Pre-written test cases tend to stick to the expected, the so-called happy paths. But mobile users, they don't follow a script. Their behavior is messy, unpredictable, and often nonlinear. That's where intuition, skill, and deep domain knowledge come in. Experience-based testing techniques help us explore those unexpected paths, the real-world scenarios that reveal hidden issues and improve the overall user experience. Exploratory testing is all about learning on the fly, designing tests, and executing them at the same time, without being tied down to strict scripts. Then there's persona-based testing, where we step into the shoes of different user types, like the power user, the impatient buyer, or someone with vision challenges, to see how the product holds up through their eyes. And finally, fault attack, or error guessing, which means pushing the interface to its limits, pasting huge chunks of text or hammering buttons rapidly to uncover hidden issues. These are the core experience-based techniques we rely on. Let's dive into tour-based testing strategies. This approach guides us through the product like a user would, exploring features step by step. It's less about rigid scripts and more about discovery, uncovering issues by navigating the system naturally. By thinking like a user on a tour, we catch problems that scripted tests might miss. It's a powerful way to blend exploration with structure, helping us build better, more intuitive experiences. Next, we dive into two unique testing strategies: the Clutter Tour and the Intellectual Tour. The Clutter Tour pushes the app to its limits by flooding the phone with data. Imagine 10,000 photos, 0 free storage, and 50 apps running in the background. It's about seeing how the app handles real-world chaos. Then, the Intellectual Tour challenges the app with complex, unexpected questions, like what happens if you try 3 conflicting promo codes at once. Both tours reveal how robust and smart the app really is. Tour bring focus to exploratory testing. Rather than wandering aimlessly, a sabotage tour sets a sharp goal. For the next 30 minutes, you're trying to break the app. You push it hard, forcing crashes by messing with system conditions it might not expect. This approach turns testing into a deliberate challenge, helping us uncover weaknesses that random clicks might never reveal. It's about thinking like a saboteur, finding cracks before real users do. Let's walk through the mobile test process lifecycle. This is the journey we take to ensure an app works smoothly on every device it touches. From planning and designing tests, to executing them on real phones and tablets, and finally analyzing the results, each step builds on the last. It's a cycle of continuous improvement, helping us catch issues early and deliver a seamless user experience every time. When we talk about adapting traditional testing to mobile agility, it's all about staying flexible and thorough. First, we define our target device matrix, which devices and platforms we need to cover, and set up the right toolchain. Then, we configure emulators, real device clouds, and prepare test data to create a solid environment. Execution blends automated regression tests with manual exploratory checks. Finally, after release, we keep a close eye on crash rates using tools like Firebase Crashlytics or Sentry. It's a full cycle, from planning to monitoring, designed for speed and quality. Now let's look at a sample exploratory test charter. This is our guiding document, a clear mission for what we want to explore during testing. It sets the scope, the focus areas, and the goals. Think of it as a map for discovery, helping us stay curious but purposeful. With a solid charter, we can dive in confidently, knowing exactly what questions we're trying to answer. It keeps our testing sharp and effective. When it comes to mobile testing, we can't rely on just one method. Field testing, crowdsourced beta testing, and App Store compliance checks are essential parts of the process. They catch issues that scripted tests often miss. That's where exploratory testing shines. It's unscripted, real-world, and reveals hidden problems. Tour-based testing gives us a structured way to explore. And remember, testing doesn't stop at launch. Continuous monitoring, like crash analytics, keeps us informed and ready for the next sprint. This approach keeps mobile apps reliable and user-friendly. That wraps up our session today. We've explored how to draft a focused Clutter Tour charter, targeting real-world distractions that challenge driver tracking screens. Next time, we'll dive into mobile platforms, comparing emulators, simulators, and real devices, plus how to set up test labs in the cloud and on physical hardware. Now, let's open the floor for your questions and get hands-on with the practical assignment. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.